If the government or NASA had said to you that the Earth is stationary, imagine that. And then imagine we are trying to convince people that no, it's not stationary. It's moving forward at 32 times rifle bullet speed and spinning at 1,000 miles per hour. We would be laughed at. We would have so many people telling us, "You're crazy. The Earth is not moving." We would be ridiculed for having no scientific backing for this convoluted moving Earth theory. And not only that, but then people would say, "Oh, then how do you explain a fixed, calm atmosphere and the sun's observable movement? How do you explain that?" Imagine saying to people, no, the atmosphere is moving also, but is somehow magically velcroed to the moving Earth. The reason is not simply because the Earth is stationary. So what we are actually doing is what makes sense. We are saying that the moving Earth theory is nonsense. The stationary Earth theory makes sense, and we are being ridiculed. You've got to picture it being the other way around to realize just how ridiculous this situation is. This theory from the government and NASA that the Earth is rotating and orbiting and leaning over and wobbling is absolute nonsense. And yet people are clinging to it tightly, like a teddy bear. They just can't bring themselves to face the possibility that the Earth is stationary, though all the evidence shows it. We feel no movement. The atmosphere hasn't been blown away. We see the sun move from east to west. Everything can be explained by a motionless Earth without bringing in all these assumptions to cover up previous assumptions gone bad. If you find from your own experience that something is a fact and it contradicts what some authority has written down, then you must abandon the authority and base your reasoning on your own findings.
Foucault's pendulums are often quoted as proof of a rotating Earth, but upon closer investigation prove the opposite. To begin with, Foucault's pendulums do not uniformly swing in any one direction. Sometimes they rotate clockwise and sometimes counterclockwise. Sometimes they fail to rotate, and sometimes they rotate far too much. The behavior of the pendulum actually depends on 1. The initial force beginning its swing, and 2. The ball and socket joint, which most readily facilitates circular motion over any other. The supposed rotation of the Earth is completely inconsequential and irrelevant to the pendulum's swing. If the alleged constant rotation of the Earth affected pendulums in any way, then there should be no need to manually start pendulums in motion. If the Earth's diurnal rotation caused the 360-degree uniform diurnal rotation of pendulums, then there should not exist a stationary pendulum anywhere on Earth.
The Foucault pendulum is an assumption. It's an assumption. It's an assumptive belief, assumptive theory, and assumptive proof that the Earth spins. And that's what causes this thing to move, usually in a clockwise position as it moves throughout the day. But did you know sometimes it moves counterclockwise? Did you know it almost always moves at different speeds? And as I showed here, a man named Elias discovered that when solar eclipses occurred, that the Foucault pendulum would drastically change its pattern and actually even reverse many times during a solar eclipse.
الآن مسألة دوران الأرض حول نفسها هذه طبعا لم تكن سهلة الإثبات. اليوم ثابتة وواضحة عندنا بسهولة جدا. أولا أن لدينا أقمار صناعية ومركبات فضائية تصور لنا الأرض، ويمكن أن تصورها بعد ساعة وساعتين وعدة ساعات وترى أن أجزاء الأرض وألوان الأرض تتغير. كذلك نرى كل الأجرام، كل الكواكب، بل حتى الشمس نراها تدور حول نفسها بسرعات مختلفة. نرى البقعة الشمسية، نرى البقعة الحمراء على المشتري إلى آخره تدور، وبالتالي فكل شيء يدور في الكون، ونعرف كيف نفسر لماذا هذه الأجرام تدور حول نفسها.
Throughout thousands of years, the same constellations have remained fixed in their same patterns without moving out of position whatsoever. If the Earth were a big ball spinning around a bigger sun, spinning around a bigger galaxy, shooting off from the biggest bang, as NASA claims, it is impossible that the constellations would remain so fixed. Based on their model, we should, in fact, have an entirely different night sky every single night and never repeat exactly the same star pattern twice.
The other thing that's about the spinning Earth is looking at the stars. Now, directly above the axis of spin is the pole star, Polaris, okay, directly over the North Pole. And we're told that the reason that all the stars spin around the North Star is because the Earth is spinning at 1,000 miles an hour. Okay, seems to make sense, because if you put a long exposure camera pointing at the North Star, you'll see the stars will make perfect circles around, perfect star trails. The only problem is the Earth is also orbiting the Sun at 67,000 miles an hour. Okay, the Sun is moving, dragging the Earth and all the planets up that way or that way at 600,000 miles an hour. So why do we see perfect circles? You know, because that's the slowest speed, that's slowest motion in that mix, and yet the Earth is moving 67 times faster that way and 600 times faster that way. So you should see the stars do all sorts of strange motions, but you don't. You only see them make these perfect circles. That tells me that it's the stars that are moving, not the Earth.
If Earth were a spinning ball, it would be impossible to photograph star trail time-lapses turning perfect circles around Polaris anywhere but the North Pole. At all other vantage points, the stars would be seen to travel more or less horizontally across the observer's horizon due to the alleged 1,000-mile-per-hour motion beneath their feet. In reality, however, Polaris's surrounding stars can always be photographed turning perfect circles around the central star all the way down to the Tropic of Capricorn. It would actually be impossible for star trail photos to show perfect circles even at the North Pole. Since the Earth is also allegedly moving 67,000 miles per hour around the Sun moving 500,000 miles per hour around the Milky Way, and the entire galaxy going 67 million miles per hour, these four contradictory motions would make star trail time-lapses all show irregular curved lines. If gravity magically dragged the atmosphere along with the spinning ball Earth, that would mean the atmosphere near the equator would be spinning at over 1,000 miles per hour. The atmosphere over the mid-latitudes would be spinning around 500 miles per hour, and gradually slower to the poles, where the atmosphere would be unaffected at 0 miles per hour. In reality, however, the atmosphere at every point on Earth is equally unaffected by this alleged force, as it has never been measured or calculated and proven non-existent by the ability of airplanes to fly unabated in any direction without experiencing any such atmospheric changes.
As you say, the globe is spinning at 1,000 miles an hour. Neil deGrasse Tyson, who's a leading astronomer in America,
I'm Neil deGrasse Tyson, bitch.
Tells us that the Earth is not a perfect circle, it is actually an oblate spheroid. It's squashed and wider at the equator. Yeah?
So Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate, and officially it's an oblate spheroid. That's what we call it.
So my question to him would be, why is there land at the equator? Because water will move more readily than rock. So if the Earth is spinning, the water will be collected at the equator. I mean, if you spin a wet tennis ball, okay, you spin a wet tennis ball, the water shoots off at the equator, essentially. So all the water will be gathered around the equator. So why is there land at the equator? Doesn't make any sense.
So imagine this is the ocean floor down here. This is the top of the ocean. And again, if you think, well, this is in a closed container, that's why. Fine. Fill up a swimming pool with water. Take a square one, a rectangular one like this rectangular here, and tell me if it acts like this. Because as soon as that water gets in there, it's subject to the rotating force of the Earth. Is it not? Is not this thing, this water in here, subject to the same gravitational forces as are on the Earth? I mean, this experiment isn't being done in outer space. It's not being done on a little spacecraft or something like that that's out there somewhere. This is on the Earth, exact same forces of the Earth, except for the spinning action we're going to show here is going to be much slower. And let's watch what happens. And let me mute it because the sound doesn't matter. That's another thing to get into, sound. And how sound moves 750 miles per hour, but we're able to speak to somebody to the east as much to the west. Look at that. Look, and we're going to see this slower. The horns of water is what everybody would call it, because every container that held water would have horns like this. From the glass holding in your hand of water to the ocean. Look at that. Is that what you see in nature?
يعرف في الفيزياء مبدأ مهم، هو أنه إذا كان لجسمين كثافتان مختلفتان فإنهما لا يتحركان بنفس السرعة. ومثال على ذلك بسيط، مثلا إذا أخذت عصا في يدك وحركتها في الهواء بسرعة ما فإنها تتحرك. أما إذا أخذت مثلا بالونا مملوءا بالهواء فإنه سيتحرك بسرعة أقل. لذا مثلا الأرض بمائها وهوائها وصخورها فإنها تدور حول نفسها بسرعة 1600 كم في الساعة، وتدور حول الشمس، وهي والشمس يدوران في فلك، والشمس والمجموعة الشمسية كلها تدور في المجرة، والمجرة نفسها تتحرك. فخلال كل هذه السرعات وهذه التحركات كيف يعقل أننا نحس بالثبات، وأن الأرض ثابتة لا تتحرك، وأن الهواء في مكانه، وأن الماء في مكانه، وأننا لا نحس بشيء؟ والسبب المنطقي الوحيد الذي يقولون أنه سبب كل ذلك هو الجاذبية. فكيف يمكن للجاذبية أن تجعل الهواء في مكانه يتحرك بنفس السرعة التي تتحرك بها الصخور، والماء كذلك؟
كسوف الشمس الذي حدث في 20 مارس آذار 2015 حسب الملاحة الجوية. الشمس ثابتة، القمر يدور حول الأرض نصف درجة خلال ساعة، الأرض تدور 360 درجة خلال 24 ساعة. بدأ الكسوف عند خط طول 20 شرق خط غرينتش، فإن حركة القمر تتوافق مع حركة الكسوف. بينما لو أن الأرض تدور من الغرب إلى الشرق لانتهى الكسوف عند خط طول 60 غرب خط غرينتش، بينما في الواقع انتهى الكسوف عند خط طول 81 شرق خط غرينتش. نعيدها مرة ثانية. بدأ الكسوف عند خط عرض عند خط طول 20 شرق خط غرينتش. القمر يدور من الغرب إلى الشرق وحركة الكسوف تتوافق معه، بينما إذا كانت الأرض تدور من الغرب إلى الشرق فسوف ينتهي الكسوف عند خط طول 60 غرب خط غرينتش. بينما في الواقع أنت عند خط طول 81 شرق خط جرينتش، وهذا دليل على أن الأرض لا تدور حول نفسها ولا حول الشمس.
The other thing is that, you know, we have senses to be able to sense acceleration. You know, you get in a car and somebody puts their foot down, you know, and you get thrown back in your seat. You can feel the acceleration. Yeah, you can feel changes, very minute changes of acceleration. So how is it that if you live up here in Macedonia, yeah, which is spinning at maybe 700 miles an hour, yeah, because the speed it's spinning is slower than this speed. So if you took a flight down to Africa, yeah, on the equator, why don't you feel the change in acceleration? Yeah, so why don't you feel the change in acceleration? You know, you have these senses that will register the slightest change, yeah? But you get off the plane there and you don't feel dizzy, you know, because now you're moving a lot faster. So, no, it doesn't make sense.
Pour répondre à l'argument de Charlie, qui n'est pas d'ailleurs le seul à avoir recours à cet argument, pour expliquer le fait qu'on ne sente pas la rotation de la Terre. Charlie dit, je n'ai pas le texte sous les yeux, mais il dit quand on est dans un avion qui vole à 200 km/h, je ne sais pas si c'est la bonne vitesse, mais bon, c'est ce qu'il dit, on ne le sent pas parce que tout simplement on se déplace en même temps que l'avion, et pour la Terre c'est pareil, on se déplace en même temps qu'elle, donc on ne sent pas son mouvement. Alors cet argument est-il valable? Alors d'abord, c'est vrai que si on est dans un avion qui a une vitesse constante, qui se dirige tout droit devant lui, et que les fenêtres ne sont pas ouvertes, ce qui est le cas en général, les fenêtres de l'avion ne sont pas ouvertes, et qu'on a les yeux fermés, on peut ne pas sentir le mouvement de l'avion, ça c'est vrai. Mais il s'agit d'un mouvement rectiligne et régulier. Supposons qu'il y ait un petit trou d'air, ou supposons que l'avion accélère ou ralentisse, on va le sentir. Donc, on peut ne pas sentir le mouvement d'un moyen de transport qu'à condition que l'objet, enfin que le moyen de transport, se déplace à une vitesse régulière, constante, hein, et se déplace de façon rectiligne, tout droit. Est-ce que la Terre est censée se déplacer de façon rectiligne? Il me semble que non. Il me semble qu'elle est censée tourner sur elle-même et tourner autour du Soleil. Autrement dit, elle a deux mouvements combinés, deux rotations combinées. Or, quand deux mouvements se combinent comme ça, c'est-à-dire qu'on a une rotation plus une autre rotation, quand on a la combinaison de deux mouvements, on n'a jamais affaire à un mouvement constant. Il y a forcément des accélérations et des décélérations. Donc, non, on devrait le sentir, puisqu'on a un mouvement qui est irrégulier, qui n'est pas d'une vitesse constante. De plus, même si le mouvement était complètement régulier, et que c'était une rotation simple, supposons par exemple que la Terre tourne sur elle-même, et c'est tout, eh bien, on le sentirait, dans la mesure où quand on est par exemple sur un manège dans une fête foraine, et que ça tourne à toute allure, on le sent. On le sent dans son corps, on sent la force centrifuge, on la sent. Donc, même si c'était une rotation simple, on la sentirait. Et une double rotation, on devrait la sentir encore plus, puisque c'est un mouvement plus complexe et donc moins régulier, avec une vitesse moins constante et des changements de direction. Voilà, premier point. Second point, supposons maintenant, imaginons que la Terre se dirige d'une façon, se dirige selon un trajet rectiligne dans l'espace à une vitesse constante. Est-ce qu'on le sentirait ou pas? Eh bien, on revient avec la comparaison avec l'avion. Dans l'avion, pourquoi est-ce qu'on ne sent pas la vitesse? Ben, la réponse est évidente si on réfléchit, enfin il faut réfléchir un petit peu quand même, mais on ne la sent pas parce qu'on est à l'intérieur de l'avion. L'avion est clos, il est fermé, et donc étant à l'intérieur, on est à l'abri du vent de la vitesse, de l'atmosphère, donc c'est pour ça qu'on ne sent rien. Mais la Terre, quand on est sur la Terre, on est à l'extérieur. Donc, s'il fallait comparer avec un avion, il faudrait comparer avec un avion. Avec un avion, oui, mais un avion 1 qui ferait des loopings, qui montrait qu'il descend sur des loopings. Donc, est-ce qu'à l'intérieur de l'avion, on sentirait qu'il bouge? Oui, ça c'est 100%. Et non seulement, il faudrait comparer avec ça, mais il faudrait aussi comparer avec, non pas quelqu'un qui est dans l'avion, mais quelqu'un qui est sur l'avion. Donc, il faudrait imaginer, par exemple, Mission Impossible numéro 5 ou 6. On est Tom Cruise, on est accroché sur le dos de l'avion, qui est en train de faire des loopings et de faire des cabrioles dans l'air. Est-ce que là, on sentirait que l'avion bouge? Je crois que la réponse est dans la question. Non seulement on le sentirait, mais on aurait vraiment un horrible mal de mer et on vomirait tous ces boyaux toutes les 5 minutes, tellement on serait secoué dans tous les sens. Et puis en plus, il y a un autre point, c'est que pour que Tom Cruise ne tombe pas, il faudrait qu'il s'accroche avec les deux mains là, très solidement à l'avion. Nous, est-ce qu'on s'accroche à la Terre pour ne pas tomber dans l'espace? Je ne crois pas. Donc, dès qu'on creuse un petit peu cette analogie, qui, si on n'y réfléchit pas trop, enfin si on n'y réfléchit pas du tout, peut paraître bonne. L'analogie avec l'avion, oui, après tout, on est dans l'avion, on ne le sent pas, et pourtant il se déplace parce qu'on se dépose en même temps, ok, donc on sent rien, c'est pareil, la Terre, ça se passe en même temps que la Terre, donc on le sent pas. Non, ça marche pas du tout comme ça, dès qu'on creuse un peu, on voit bien que c'est absolument pas crédible cet argument. Au contraire, il se retourne contre la personne qui l'avance, parce que clairement, si on creuse un peu cet argument, on voit bien que ce qui tend à prouver, c'est que justement, sur la Terre, on devrait non seulement sentir le mouvement, mais le sentir d'une façon hyper violente, et même, on ne devrait même pas pouvoir y rester sur cette Terre. On devrait déjà être vraiment, avoir viré dans l'espace, quoi, avoir été projeté, expulsé très très loin, très très vite, quoi, depuis des millions d'années, enfin, des milliers d'années. Voilà, donc ça c'est pour dire que l'argument du type, bon, vous avez compris ce que je veux dire, voilà, cet argument n'est pas du tout valable. Alors, du coup, on se pose la question, pourquoi ne sent-on pas la rotation de la Terre? Eh bien, la réponse, elle est claire, on ne sent pas la rotation de la Terre parce qu'il n'y a pas de rotation de la Terre, voilà.
In my last video clip, some folks said that they didn't understand or didn't quite get how this video sequence of the midnight sun, how it proves that the Earth is flat and that the sun is orbiting around a flat Earth. So some people will tell you, no, this video footage is filmed from a man who's standing on a spinning ball and the sun is fixed. He's on a spinning ball and he's filming the sun. So let's have a look. Is this filmed from a man on a spinning ball? So let's look. So remember, the sun is fixed at the Earth center and the Earth is leaning over at 23.4 degrees, and the man, he's turning in a circle and he would be filming the sun. So what would he see? Would he see that sequence that we saw? So let's look closer at the man and the Earth if he was on a spinning ball. You see, if the man was on a spinning ball, he's spinning around the North Pole, which is the red arrow. The mountains would rotate around him. You see the numbers rotate around him. But he's always looking forward. He's looking in the same direction. He's not looking behind him. He's facing the same direction. He cannot turn around and film behind him. So to help us understand this, imagine a train wheel. Right, the wheel turns on its axis. It's got a shaft, and the shaft is fixed off center. Right, so the shaft moves forward, it pushes the wheel, and the shaft comes back and pulls the wheel around. Okay, so the wheel rotates and the shaft is off center. So we're not gonna, don't focus on where the shaft is pointing. Look at the wheel and the position of the shaft, and so what do you see? Right? So basically this is what should be happening with the man who's filming the footage. So do you see there's a couple of issues already that should be happening in that video footage that's not happening. So if we put a man on top of that shaft, the first issue is, as the man turns, he'd be crossing the light source, so the blue line in the middle, right, where the sun is. He'd be crossing over the sunlight, backwards, left and right. But in the footage, the light is actually following him. So the point is the cameraman, he is moving. And it's his video footage of the sun. He's moving from left to right. So therefore, the sun would have to zigzag. In other words, I've got a man here, I put numbers around him. Right. You see, the numbers would turn, but he's facing the beer. He's not turning 360. All he's simply doing is he's turning to his right. Now he's pointing back forward, and now he's pointing to his left. He's not rotating 360, because if he did rotate 360, the beer would be behind him. You can't see the beer all the time. And did you notice? Look at that again. Now look at that and look at the numbers. You see, as he rotates, the numbers rotate with him. So as he looks at the sun, you see 1, 2, 3, they're all passing. Right? And now 1 passes, 4 passes him, now 1 passes him again. But if he rotated, you see, he'd be looking at the same number in front of him, and the beer would be behind him. So, if we apply that to the video footage, the cameraman is looking at the sun, he's not rotating. And the numbers, so the numbers in this case would be the mountains, so the mountains would rotate around him, but also the clouds, because the clouds are supposed to be spinning with the earth, and the sun is fixed. Now the man isn't spinning around 360 degrees, we've established that. He's just looking at the sun. So he's angled, the sun is on his right, he's turned towards right, and now he simply points forward again. He's looking at the sun, and now the sun is on his left, and he's just simply turning the camera towards the sun. You see, this is not what we're seeing in the video footage. So if I had locked my camera onto the man, the sun would indeed loop, do a circle. And from your perspective, the sun would move from left to right. You see, and the mountains would be turning around you. The sun cannot turn completely around with the mountains. That's the point. Do you understand that? So the sun is moving up and down. Right? So the sun, if we can use another term, is zigzagging up and down. So what is causing that zigzag? So I'll say no. What's causing that is the tilt, the 23.4 degree tilt of the earth, because the man is leaning backwards and now he's leaning forwards. Then he leans backwards and forwards, that's what's causing the tilt. Well, then you have a big problem. You see, the man if the tilt, if that is caused by leaning backwards and leaning forwards, you see, he's leaning the same distance to the left and to the right. How can he only register his backwards and forwards motion? You see, the North Pole is in the center and he's spinning around the North Pole. It would have to register motion, left, backward, forward, his complete motion. You can't just film the up and down motion because he's not just moving backwards and forwards. He's moving in a circle. So, the sun then, if he was on a spinning ball, should move in a circle. Now listen carefully. Some people, even in the flat earth community, don't want you to look at this video footage and analyze it. They'll say, no, the sun is too far away for it to show any motion. The point is, it is showing motion in his video clip. The sun is moving up and down. So you cannot argue then that the sun is so far away that it doesn't show any motion. The sun's motion is registered, it's up and down. You see, if we are on a ball that is angled at 66.6 degrees, your angle on that surface is at 90 degrees to that ball. So if you are turning, it doesn't matter which direction you're turning in. Every 180 degrees, your angle would be at the opposite angle. Right? So keep this in mind. Another issue is what would you see then? Would you be able to see around the curve of the ball? Because remember, the sun is fixed at the plane, at the same plane the earth is on. Also speed. You see, if you're on a spinning ball, if you are spinning in an arc, the sun would slow down and then speed up as you move across the face. And as you move away from the sun now, it would slow down and speed up, slow down and speed up. When we look at the footage, we see that the motion of the sun is constant in relation to the earth, same speed. So that's one issue. Another issue is the light itself. Remember, the sun is fixed at the center of the earth, right? How can the sun then reflect in the water where the cameraman is? The sun would have to be above him. So look, you always see the sun all the time in the water, reflected in the water. This wouldn't be possible if you're on a spinning ball.